So I left you with this problem about the right triangle. Let's see if you got it. Here's my answer right there. It all fits pretty neatly on the screen. So I went ahead and drew the right triangle. The hypotenuse is 10, and they said one leg is 3 times the other. So if I label one of them x, I'll make the other 3 times x. And applying the theorem, I know 3x squared, like this, plus x squared equals 10 squared. One thing people sometimes tend to forget is the parentheses on the 3x. We do need to square that entire thing. So when we start to simplify, 3x quantity squared is 9x squared plus x squared. And oh, looks like I messed up. 10 squared, that should be 100. And I think I carried through that mistake the whole way. Oh my goodness. So then when we add here, 9x squared plus x squared is 10x squared, but this should equal 100. Now what we can do, we don't need the Pythagorean theorem, not Pythagorean theorem, we don't need the quadratic formula here. We can solve this with the square root property. If we divide by 10, then we get x squared equals 10. X squared equals 10. And now here's where my mistake caught up to me. What is the square root of 10? 3.16, and it said to round to 2 decimal places. So, oh my gosh, look at all this. So we'll take the positive version, and there's the negative version. Of course, only one answer. We just want the positive side. We're talking about the length of a triangle. So one of the legs will be 3.16 centimeters. And the other will be 9.48 centimeters if we round to 2 places. Okay, well hopefully you did better than I did, and you got that one right. Let's move along. It's example number 3 about falling objects. Okay, let me read it. Donnie is standing at the edge of an ocean cliff. He throws a rock that travels upwards and then falls into the water below. After t seconds, the height of the rock is given by this function. H of t equals negative 16t squared plus 70t plus 90. Okay, so to just give you an idea, and you can probably imagine what's happening, but you know, there's this cliff, and there's the water down here, so there's a cliff. And so Donnie is standing there, and he throws this rock, and it goes upwards for a little bit and then falls down into the water. And he's pretty high up there when he throws that rock. So it really gets some good travel airtime. Okay, so part A says, after how many seconds will the rock hit the water? How long is it traveling before it splashes down into the ocean? Think, well, how are we even going to start this? How many seconds? Okay, well, let me ask you this. When that rock hits the ocean, what's the height? Isn't the height at that moment 0? The moment it hits the ocean, it's not up above anywhere. It's at a 0 height. So what we're going to do, I guess I'm asking the question there, what's the height as the rock hits the water? And the height is 0. So we're going to put 0 in for h. Actually, this entire thing will become 0. And then we're going to try and find the value of t. So here's the equation that we're attempting to solve. 0 equals negative 16t squared plus 70t plus 90. And Yeah, you just have to go back and remember function notation, that h of t, that entire thing is describing the height. So we're going to make that whole thing a 0. Okay, well, at this point, hey, we've got the equation. We can just go for quadratic formula right here. So our a is negative 16, b is 70, c is 90. Plug those all in. T equals all that. Okay, and I'll kind of go through this sort of quickly, right? We want to calculate what's inside that square root. Turns out it's 10,660 under there. And our denominator is negative 32. Again, here we're going to end up rounding. So at this point, I just wrote it as the two separate parts. One with adding, one with subtracting. And then went and calculated both of those. And I know that takes a moment to do this when you're working it out. So I know I'm going a little bit too quickly here, but let me pause, slow down at this moment, see if you can calculate those two values of t. For the first one, when you're adding negative 70 plus the square root of 10,660 all over negative 32, this is the rounded version, negative 1.0. I think there's like a 3 or something after this, but that's the way it would round to 1 decimal place. And then when you subtract, it ends up turning, the answer turns positive 5.4. So here, of course, well, I guess, make sure you can get these two decimal answers. And again, we think, wait a second, negative time, we don't care about that. How long does it take before that rock hits the water? 5.4 seconds. Spends quite a bit of time up in the air. That's a long time for that rock to travel. He was pretty high up on that cliff. Okay. Let's look at part B. I don't want to reveal anything yet. Let me read the problem. At what time or times will the rock reach 160 feet? So here's the idea. He's up there really high. He's going to throw this rock upwards, and he's really got an arm on him. Let's say this is a height of 160 feet. It's very likely that there's going to be 2 moments when that rock passes through 160 feet. Okay. So if we get 2 answers here, that actually won't surprise us because it's got to go up and then come back down. Okay, so what we're going to do is take our height to be 160, and we're going to go about finding t. Okay. So we'll just put a 160 there on the left, equal to the negative 16t squared plus 70t plus 90. And we want to use quadratic formula here, but there's something to do first. It has to be equal to 0, so we're going to subtract that 160 to the other side, leaving us with a minus 70 over there. Okay, and then we'll go for our quadratic formula with our values of a, b, and c. Plugging all that in. All right. Simplifying a little bit, you end up with 420 under the square root. And then, I know I'm going, hopefully you're writing all of this down. I know I'm going too quickly, but just because we've done this so many times now, we'll get the one where we add the 420, one where we subtract, and we come to our 2 decimal answers. And both of those are our answers. We're not going to disregard either one. It does happen twice, and I kind of drew it again down there. At 1.5 seconds and at 2.8 seconds does that rock pass through 160 feet. Okay, well that does it for 9.5. I will see you guys at the live session.